This talk is about cluster scale problem solving, which is a little weird because it's less about the technical problem solving and more about how to get clusters to solve problems. But by way of introduction, I'm Kellen. I am a sustaining engineer at Canonical. We support Ceph for our customers. I've been supporting Ceph for about 6 years now, and we do everything from bug fixes to performance tuning for customer clusters. All right. Yay, it worked. This talk is about building a bridge between our technical problem-solving capabilities, which lots of companies, lots of people have, and to building a bridge to solving the organizational problems. In my role at Canonical, we often get the following. Health OK is not enough. We get customers with health OK clusters that just aren't able to keep up with whatever workload they're running. And they come to us and go, please make it fast. And this talk is a little bit about how you go about doing that in a way that satisfies people, because those of you who are storage administrators have probably shared my ire when someone says, can Ceph go fast? And you go, define fast. So, I'm an engineer, so there's a process involved. Sorry. First, you have to qualify what you want the cluster to do, then quantify, achieve consensus, then do all the technical magic that Ceph allows you to do to make that happen. And then my favorite part, documentation, because it's no good to go through all this exercise if you don't write down what you did, so that in 2 years, future you can go, wait, why did we set this? And have an answer without going spelunking. So, qualify. We're using qualities in this sense as less like build quality and more like it is read. What does it need to do? You can gather this using my favorite word, squishy. Ceph should be fast. And then it becomes an exercise in asking questions to clarify the qualities down to something more specific. The cluster needs to support our current VM workload. That's a quality that you can actually design for. And my favorite word here, document. You have to write it all down. So, one, so that people can agree that what you're saying and what they're saying are the same thing. And two, it comes in for the next step. You need to take that list of qualities and quantify them, because Ceph being fast enough for the VMs is not something that you can solve for. You can solve for it needs to do 100,000 IOPS, but what you can't solve for is fast. So you want to, while you're gathering qualities and quantifying them, go through and group by workload, and there will be overlap. But that's good, because you want to take that overlap and see what it tells you about the tuning or cluster design, depending on whether you've got an existing cluster or a new one, and go through and just get all the things that you want to measure, just the units. Because if you focus too much on a specific number of IOPS, that can cloud your thinking. And then, this is the fun part, at least for me. You engage with technical experts to understand their workload. So you talk to the backup administrator. Does VM back things up in giant 1 gigabyte chunks, or does it do 4 megabyte chunks? Or does it do 32 kilobyte chunks? Does it do file-based? You need to understand what each workload looks like on a very granular Ceph-specific scale. And now you have information on what the workload looked like and the units that you care about for measuring the cluster. You can then set benchmarks using those units. And document. Because again, if you don't write it down, you're going to be redoing the work later to figure it out again. Consensus. This is the step I see people miss most often, is they will go through, they will quantify, they will qualify, they'll do all sorts of great stuff, and then they won't get consensus. They won't go to the backup administrators, the users, the administration, what have you of the organization, and get everyone to say, yes, this is what we want. And that comes back later. So, round everything up, document it all nice and neat in one place, and come to a consensus and use something like sign-offs to verify that people have read and understood the document and agree that it is what they want. Technical problem solving. This is the fun part of my job, and you want to document everything. Not super formally, a notebook is fine, but you want to avoid confusion and unnecessary repetition. There will be repetition as part of the process, but you don't want to be repeating a benchmark because you forgot to write down what the results were. And you want to avoid anti-patterns. I highlight the streetlight anti-pattern here because it is very common for us to focus in on something that is easy to measure, as opposed to measuring what we really want to measure. So you need to understand what your tests measure, and make sure that you're not measuring things because they're easy, you're measuring them because they're relevant. And avoid copy and paste. The internet is a wonderful thing. Stuff from the internet is not always wonderful. Usually solves a slightly different problem, even if it sounds right, and it might be outdated. You might be using Ceph configs that were useful in Nautilus, and they are not so great for Quincy. And finally, assuming you go through all this process and you have a working cluster that does what it's supposed to do, document, document, document. It seems like you've made masses and masses of documentation, hopefully, during this process. You want to take the time to do a retrospective and condense that down to a single digestible format. Here's what we wanted, here's what we did, and here's what we got. Because you don't want to have to go through 200 pages of notes and benchmark results and testing methodologies to figure out why you did something. You want to read the 5-page summary. So I've got some more benefits up there. And setting aside the technical stuff, the key one here is it demonstrates to non-technical stakeholders that what you promised was achieved. And the secret sauce that I have learned from working at Canonical is communication, communication, communication. You want to make sure that you are communicating not just at each other, but with each other. And that particularly involves active listening, where you listen to someone and then rephrase what they said in your own words back to them so that they can go, no, that's not what I meant. I meant something else. You want to be engaged in active listening to come to a meeting of the minds on your requirements. And I like to say concise, accurate, and written communication. Written communication is key, not to catch anyone out on anything, but so that everyone can go back and look independently when they go, oh, what was that? At least if you're me. I have the memory of a goldfish when it comes to things in email. So, that is my quick talk on cluster scale problem solving. Any questions? And if you have a question, please go to the mic. Ooh, I did a really good job. No questions, or I was really boring. One of the two. All right, well, thank you, everyone.